Hello, today I want to use a dataset from the Kaggle, which is basically this California housing prices, and I want to implement three models. So let's dive straight in. So for this, I've divided into two ways. The first thing is the demonstration of the coding, how it works. And the second thing is we can go through the details while we are working on the code. Okay, so to not waste time, I already have the code ready in its place so that it won't take much time to explain these concepts and we can utilize this time efficiently. The first cell, whatever you see here is, these are all the import statements. The main thing you need to just see it about is of this Kaggle hub, which I'm getting it from the Kaggle dataset adapter. If you don't have this particular packages, you can just use this pip install and get it done. And the first thing where I want to store the file once I get downloaded from the Kaggle, in specific in the root folder, and other thing is what is the name I want to give it to that particular CSV file. And if you see this, when I run this, it will go and get that data set, download it, unzip it, and also it will store that data in particular data frame called housing. Let me run it and see it. So if you run this, the particular data, what I'm talking about, this California housing prices, you have several columns that will have this longitude, latitude, where exactly the particular house is located, what is the age, total rooms of the each house, total bedrooms, and the population of that area, households, number of households, the median income and the house value, and ocean proximity. This is nothing but where that particular house is there. It's nearby the ocean or it's in inland or something like that, right? This is the whole data set. Now, let's try to get some info of this columns. It is very similar. I think if you went through the pandas, it's very easy. It's just with dot info, the data frame, and with dot info. If I run this, the particular thing you can see here is for each column, it will tell you what is the data type and if it has nulls or not nulls. If you see out of this all the columns, the number is 20,640. And if you see in this total bedrooms, 20,433. That means the remaining whatever we have it, those are nulls, right? That is the first thing. And now to see that in the format of a sum graph, we chose the histogram and we are just finding out on the specific column called median house value. If you see here, the median house value, which is here. Okay, and we are trying to divide that into 50 bits. Maybe it's from 0 to 100,000, 100,000 to 200,000, 200,000 to 300,000. Like you will have around this 50 bits. And this is all about the titles and everything. Let's run and try to understand the data here. And if you see this, the particularly we have X and Y axis. The X axis will have the median house value, the house, the particular price of this particular house, right? And the frequency. When you see this frequency, what it tells you is for that particular price, number of houses that are available. And if you see most of the houses that are available with certain price is of from below this to the maximum of 300,000. Right, below 100,000 to 300,000. And the most interesting thing you see here is the 500,000 of data, which you got a lot of spike here. One of the main reason here, because the maximum cap we have given that for this particular chat is of 500,000. So whatever the data after that you get it, it will always project into the maximum cap of 500,000. So that's why you see this highest cap, okay, which is not right actually, but to just understand the data on the higher level, what we can see from 0 to the 300,000, most of the house values are present with this certain number of houses, right? That is a maximum price, minimum to maximum price, most of the houses. Now let's see what is in this particular table, what is the categorical feature. The thing I just want to show you here is, if you see in this ocean proximity, we have in a format of string, remaining all are in numbers, though it has different variation of numbers. Some may be in decimal, some may be in regular integers, but this is a one value where you have that particularly in the string. For that categorical value, we will see what are the unique elements that are present in that column. Okay, if I run this, the first one, I'm doing this unique value, and I also want to find for each unique value how many counts, how many rows are there. right? If you see here, the unique values are near bay, less than 1 inch ocean, inland, near ocean, and island, right? And the counts for each independent or unique string, how many rows that has been repeated. You can get this values here. It is just very simple. You'll only use two methods here, unique and value counts, to just get it. What are the column you want to use it? We already know it's an ocean proximity, and you do this, you'll get the count and also the unique elements. Now, before we enter into this modeling, the first basic thing you need to find out if there are any null values. If there are any null values, you need to fill that with some number, right? There are like several other properties like using mean, median, or standard deviation, something, right? For this, I am specifically using a median. And I'm just writing a one-line statement. If you come down, let's understand this. Whatever the data frame I have, I'm just checking for the total bedrooms. If I go a little bit up, for example, from this information, because the info will give that information of not null and null. If we have a null values, we have to fill with some values, maybe mean, median, more, or standard deviation, whatever it is, right? And the thing is, here in the total bedrooms, we have that issue, the null issues. So now we need to fill this null values with some value, right? For this, I am using a median. And for that, if you see, this is my data frame. In this data frame, what is a column name? I want to touch it. And for that, I want to fill the value with a specific place, with a specific number. And what is that number? I just want to do the median of this total bedrooms, and whatever the value that is there, I want to replace it with the null values. That's it. Now, the other major thing you need to understand is the machine learning model works mostly, not mostly, works on the numbers, right? So usually if you have any string values, you need to convert into some numbers, or if it is a categorical feature, you need to convert into the binary columns, right? For that, what we get it, we just use what is a column that is we are using and for what data frame, and we are using this method called get dummies, right? When we have this, usually what happens, right? For an example, if I go back here in this, right, here you can see the example of this categorical feature. So what happens in the ocean proximity, if you see, there are different values like ocean, inland, near bay, something like that, right? And whatever you're doing it is for each column, from each string, you are converting into a column. For that particular row, if you have this 1H ocean, you are making it as 1. For other columns, it will be 0, because out of this 4 or 5 distinct categorical feature, for each house, it will be only assigned to one feature, and remaining will be always 0. And in same way in the inland, near bay, and 1H ocean, this is what you do it. And what you are achieving from this, whatever the string you have it, you are just trying to convert into this binary columns, which will be useful for the model prediction, right, or training. Now, the next most important thing is, once you have this data pre-processing categorical feature, right, there is another thing called the feature scaling, right? And for this feature scaling, if I go back here, let's understand what is feature scaling. You already seen the data frame. The data frame has several columns but different values. Some are, the range is different for each column. What we want to do, we want to standardize those columns, right, keeping that values around from certain number to certain number, maybe 0 to 1 or 1 to 100, like something like that, right? And we want to make it standardized, right? And how it does it, right? It looks, for example, for a column called longitude, it looks at the column, and for each row of that value, if I have 100, it subtracts the average and divides by the standard deviation. That is just the formula of it. It will use it and it will standardize those values, and whatever comments like a dot, so usually you see as a values. So for that, from the sklearn, scikit-learn, or whatever it is, right, for the pre-processing, you have a specific method called standard scalar. And what you use this, you initiate this particular object, and once you have that, you are trying to use this scalar, whatever you have to initialize the standard scalar, you are using a specific thing called fit underscore transform, and for what are the list of columns you want to standardize it. So here you have given for all the numerical columns to standardize it using this particular class of the object, and then you want to run this for all these numerical columns, which is this. So once you run this, okay, and you can see this, all the values, whatever you see here, it is converted into this standard numbers, right? And for this, all this 8 columns, which it's converted into a standardized value from around 0 to somewhat around -1 or -2 to somewhere in the +2 or something like that, or greater than 2. This is being standardized now, right? And it's R, the values will be very nearby, right? Now the other thing you want to see it here is, sometimes you may need whatever the features, you may have it, but you also need the additional features while you're training the model, right? For example, for this, what we are trying to do, we are just trying to calculate something where we can get number of rooms per the household. So it's just same thing, total rooms per household, and number of bedrooms per room. So bedrooms per rooms, total rooms, population per household, and the population and the household. We are just getting this additional features. Now what we have did, we got the data and we have checked data columns, how it is there and what are the values in it, and if there are any null values, we found it out. And the third step is, we, whatever the null values you have, we trying to convert into this non-null values, and then, which is helpful for the pre-processing. Then you have standardized it. Once you have standardized it, and also you have converted that particular feature, which is in categorical feature, in string into binary column, and then if you may need other features, you also created. And the last step before we run a model for the training, right, we have to split the data, because currently we have some data. What we have to do is, we will use some part of the data for training and some part of the data for testing. Simple as that. For this, we have two axes like X and Y axis, right? And same thing for x-axis and y-axis. If you see, we have two components of training, and x and y, two components of test, right? Now usually we split in the format of 80 and 20%. So that's why you noted this as test site 0.2. And usually they use random forest as 42. This will be a different topic. I can explain the different random states later, but here remember that we have used a random state is equal to 42. And the major things of x and y, before we divide this data, split the data like 80% training and 20% of testing, the first basic thing is, we need to drop a specific column what we are training the model to get an answer for, right? What we want to get it, if we have given some information, the particular model has to tell me like what is the median house value around that area. That's it, simple as that. So for this, we have x-axis, we have all the columns from the housing, which is all the other features. We are just removing one thing, which is called median house value, right? Once it is removed, the x-axis will be with except this particular column, and the other one, the target variable, right? What is a target variable for us? It's a median house value. That's why we removed from this x, and we are using in this particular variable called y, right? Now you use this train test split, which is from the model selection. We run this and it is divided into 80 and 20, right? Now here I want to use three different models, right? Linear regression, decision tree regressor, and also random forest regressor. And this is pretty much simple, or the basic, to just introduce to this how this model works. So let's try this and run this. Okay, now the first thing is about the linear regression. Before we run this, right, just let's understand or recap what is linear regression is, right? Usually the linear regression graph will be plotted in the between of x and y, and it will have that straight line that will be available that exactly or nearby match. It predicts whatever all the dots are nearby. You see this a straight line. This one you can call it as a regression line, and whatever the points in other color, it is called as data points, right? So to just go through this, what is happening behind the scenes, right? it will try to find a best line which represents in between the x and the y axis. And since you already know, x is called input and y is the output. So what happens once the line is fit, it will be easy to predict the value, right, of a y based on the x. So once you have this value, you'll easily know if something is called 0 to 1000. If you have somewhere around 500, the median house value will be around this, something like that. For this, usually it will form an equation called y is equal to mx plus c, and m is considered as a slope. And if you want in a max or what it is behind the scenes, you can just comment it so that I can explain for the next sessions, right? Now, the next thing is it has also an ability to minimize the error, right? So what is this? Whatever the line that is chosen here, right? This particular line and the distance between that each point and also the line is called error, right? As close it is, as less error it is. That's it. It's that simple, right? And usually you should assume this has a linear relationship, because when you have two values, it can't be curved, right? It's a straight line, which is a linear line. Usually you see this straight line, right? That is all about the regression line. Now I'll just run it. We'll see the results, how and what it is performing in the end with some model evaluation. Now the next thing we will also take about the decision tree regressor. Same way we'll understand what is it before we run this. So if you see in the decision tree regressor, the name itself says it is a tree. So what it does, it divides the data into these particular branches, right? And it predicts for each leaf. And by doing that, what happens is it will also minimize this error, because it's in turn finding out what is the best path in that particular leaf node, right? And then it gives that predictable numerical value. And here also in the same way, it will minimizes the prediction error. But how? Because the tree chooses the splits, right, in the different nodes, and the difference between the actual and the predicted values, from the difference between the actual and predicted values, it will try to reduce that particular error. It will show you that how much nearby the error will be that much low. And what you can understand from this, usually in the linear regression, it will only work for the linear relationships. And for this decision tree regressor, it is also a model which can handle this non-linear relationships also between the technical features and also what is a target variable here. Suppose the target variable is median house value here. And now for this, even you see this linear regression and decision tree, it's a simple thing. We are using the models whatever we have it here in the sklearn package. From the linear model we have linear regression, and also from the tree we have a decision tree regressor. From the decision tree regressor, we are using a fixed random state which is of 42, and same thing for this two lines, three lines are same. If you see that, if you observe it, right here, the only difference is you'll be using the linear regressor. Here you are using the decision tree regressor. That's it. And remaining the training the model, make the predictions, it is same. And if you see this first line, we are trying to fit it trying to train it between the x and the y value, whatever we have divided into 80%, and the result we are trying to predict the values based on that x test values, which is the remaining 20%, right? And the third one I just want to go through here is the random forest regressor. In this random forest regressor, which I'm using from the same sklearn, which is from the ensemble method, the random forest regressor, here if you see, this is pretty much the code is same, right? Same repetitive code. The only thing I've changed it to random forest regressor and the train, x train, y train, and we are trying to predict based on the x test. Now let's try to understand what is the random forest regressor. So the beauty of this is, what happens is the first step, it will try to build this multiple decision trees, right? And inside the small decision trees, it will try to predict for within the each tree. And once you have this multiple groups, right, it will take the average and it will get out the best possible value, try to predict the best possible value. And overall what it does, by combining these multiple models together, it will remove the noise of the data and it will perform way better than the linear regression and also this decision tree regressor. Because the only one thing you need to remember is it is combining these multiple models to get the average of these results, right? And also reduces the noise. And we can also see this point. The first basic thing is it builds multiple decision trees. That's the first basic, the major, most important point. And also what you know, it also predicts first within the each tree so that it can average the results, and which also reduces the overfitting, right? That is all on the high level about the random forest regressor. And when you see it, the total thing, whatever you see it, we have executed because the data is very low, and the random forest regressor may take a few more minutes to run it. And while it is running, let's also see this model evaluation, right? So what is this model evaluation? Once we have a model, we are just trying to find out how the model has been performed with the current data set, right? That's what it is all about, right? For this, what I'm using this R square and MSE, mean squared one, and also RMSE, right? So these are the three things I'm using it. For this, MSE, VM, for this metrics, you are only importing mean squared error and R square score. You can call it as R square score or R2 score. And mean square is something like I'm using mean squared error and Y true of Y prediction. I'm just writing this function to calculate three of the things. So this got finished in 28 seconds. So whatever you're trying to run it, you're using this three model evaluations. I don't want to deviate the topic explaining this, what is MSE, RMSE and R square. That will be again a separate topic altogether. If you want to understand what is it, please let me know in the comments so that I can have another session totally about these three things, right? And now, also once you see this particular three things, right, I want to have this evaluation on all my three different models. For what I'm evaluating the linear regression, decision tree and random forest. For that I need only two values, which is y test and y predicted, right? For this all three I'll be needing those three values. And now when I run this particular result, you see it has been evolved with a three different set of values with a for each model, right? And from this, what you can understand for the evaluation. So based on the values, whatever you see here for MSC, RMSC and R score, the basic thing you need to understand is if you want to compare these multiple models, the value of MSC and RMSC should be very low and the R square should be high for the data variance, right? If you see based on the evaluation of this model, you can clearly understand the random forest regressor has the lowest MSC and RMSC and also the highest data variance score, which is R square score. And what you can understand from this, from these three models, right, the best one is the random forest regressor and these two are the worst. So if you want to get the answer from some of the model, the better model you can use this for this is, you have other models also, for to just tell you out of three this is the best model, the better model. So this one, if you use it, you may at least predict a nearest or nearby value. So that is all this session about. And in the next session, I'll also go about this hyperparameter tuning in depth. So what is it, what it is doing behind the scenes, because it will take a lot of time even to run it. The last time I ran it took about 9 minutes. For the next session, I'll go through this hyperparameter tuning. If you have any questions, please let me know in the comment. I can explain you what is it in detail if someone has some gaps. Thank you. If you like my video, please don't forget to share and subscribe. Until then, bye.